search up that one thing.
All right, hello people that are gone. This is 1-7 transformations in the plane. I'm going to sit a little ways away from my computer, so I'll try to like shout loudly so you can still hear me. Transformations. I'm going to give you a little bit of background information. Transformations. You can either have what's called a congruence transformation, or you can have a similarity transformation. Okay, congruence or similarity. All right. Congruent. Two things that are congruent are the same shape and same size. Same shape, same size. Okay, but if two figures are similar, what's the difference? If you have congruent figures, they're the same shape, same size. If you have similar figures, they are
either same size or same shape.
They are the same shape, but
same shape but different size.
Different size. Okay, so there are different things that you can do to an object like a triangle to remain congruent, meaning like I can do something to this and it stays the same shape and same size. And then there's one thing that I can do to it so that I change it so that it is the same shape but different size, okay? So let's talk about how I can move this. And these congruence transformations are what we're going to talk about today. I can rotate it, right? If I rotate it, it's not going to change the same shape. It's not going to change the shape and size, right? I could reflect it, right? I could flip it over. It's going to stay the same shape and same size, just be in a different orientation. Or I could translate it. Do you know what translate means?
Smaller.
Nope. Translate means I'm sliding it.
Oh.
Like I'm moving it over, right? So I could translate it. And all of those things, when I do all of these things, it will remain congruent, right? The figure will remain congruent. Now, there's one thing that I can do so that it's the same shape but a different size, and this is one that we're going to talk about in chapter 3, not today, but it is something called a dilation. Do you know what a dilation is?
Make it smaller.
Have you heard of like your eyes dilating, right?
Make it bigger.
Like bigger and smaller, right? Dilations make an object bigger or smaller. So you're like doubling it in size or you're reducing it in size, whatever. Those are similarity transformations. We're not going to talk about this one today. We're only going to talk about these three. And this is a really easy section. So reflections.
Wait. What one's for similarity?
Rotate, reflect, translate. Similarity is just dilation. Okay?
This is all it is.
So if we're reflecting something, we're flipping it across like a line, right? Like you see how that's flipped, okay? If I am sliding something, I am translating it, I am shifting it somewhere, but it's staying the same orientation. And this one is a rotation. So I'm taking this thing and I'm rotating it from here to here. And this guy is something called a center of rotation. It's how I am rotating.
No way that's the same size.
Center of rotation. Well, I think it's because of the curvature of my book is making it look smaller. But anyway, it's supposed to be the same shape and same size, okay? So the center of rotation is that dot, and that's where we're rotating him around, okay? So should be pretty easy. All right, here's what I want you to do. A, B, and C are simply asking, this is what like the majority of your homework assignment is asking. They'll give you two figures and they'll say, is it a reflection, is it a translation, or is it a rotation? Label them. Go. I'll give you like 15
rotation.
seconds.
It's rotation.
Okay, label them.
Oh.
Is it a reflection? Is it a translation? Is it a rotation? Go. Yeah.
Is the homework gonna be nice like this? Or is it
Yes.
gonna be like,
Well, then
take this minus this to get this, multiply by this.
That's like a couple problems of it. We'll see. Okay, A. What are you doing on A?
Rotating.
Rotating. R-O-T-A-T-I-O-N. That's a rotation.
Nice one, Carson.
Okay, B. What are you doing to B?
Translation.
Reflecting it. Reflection. Translation is a slide, which is what this one is. I'm sliding it from here. I'm sliding it up to there. So this is a translation.
I can't
On
really
our
see
page, you
anything on
can't
my
see.
computer.
Translation. Okay? All three of those are transformations. A lot of people get translation and transformation confused. But transformation is all three of them together. Translation is just sliding it. Okay? All right. You may or may not know what this thing is. This is a skip-it, is what they're talking about. Do you know what a skip-it is? No? Oh.
The kids skip it.
Oh, you make me so sad. All right,
Oh,
so.
are you talking about the thing where you go like?
Yeah. So this little kid here has a skippet around the ankle, right? Okay, so this is what a skippet looks like. I'll just draw, like, it has a circle around one end where you put your foot. This is where your foot is, right? And you put it around your ankle, and then it has this little ball on the end here that basically is like a step counter, right? Like it counts how many times it goes around, and like you have races with your friends to see how many you can get around before like you trip and fall and break something, right? Like so, like that's what a skippet is, okay? Now they're saying if that's the deal, and this is what's happening, like this is the aerial view of what happens. So it spins around and around and around in a circle, and you just keep jumping over top of the thing as it goes around.
Kids?
Yes, I had this at recess, like every day for like 2 months.
Me and Carson just used to fight. That's it.
We used to
So,
Why
I
is
have-
our school so?
Yeah, Anyway,
Life sucks.
Is this a reflection, a translation, or a rotation?
Rotation.
Rotation. Okay, now, what is the center of the rotation?
Skip it circle.
Your foot or your ankle. Okay, the center of rotation is where it's rotating around, which is your ankle. That's the center. Okay? Alright, so go to the back side. This gets a little bit tougher, but not too bad. Okay? Alright, there are 3 sections. There is reflections, which we're going to talk about in example 3. There is translations in example 4, and there's rotations in example 5. Okay? Translations, or excuse me, reflections is the first one. They're going to give us some coordinates A, B, C. Okay? And they're over here, they're going to say reflected across the x-axis. Here, they're reflecting it across the y-axis. Okay, so I'm going to show you what this looks like, and then I'm going to show you how to cheat. Okay?
No.
A is 3, 2. It's not really how to cheat. It's like the rule, right? 2, -2 is this one, and 4, -5.
3, 2.
They're up above. These guys right here. Right there. We're plotting those guys. You see that?
Yeah.
Okay, plotting them there.
You know, this graph is very small.
I know
Yeah,
it is.
so
I know it is. I'm sorry. I should have blown it up a little bit, but it's fine. I can zoom. Ha.
Yeah.
Ha. That sucks.
Cheater.
Except this morning I couldn't find my Apple Pen, so we had to sit family style at the table and do. There was only like 4 people in class this morning. Out of
Don't
6.
you have like
Out of
5
6.
Apple
I have
Pens?
6. I have 2 of them. Well, 2
Wait,
that
I get
don't
4
work.
here.
But anyway, so we had to sit family style at the table. So I actually had to graph these like manually on the paper. I couldn't zoom in, which was really sad. Anyway.
Yeah,
Okay,
now you don't
so
have
there's
to
this
do
guy, all right? And they want us to, in this example, to reflect it over the x-axis. Which one is the x-axis?
The one that goes this way.
This one. If I reflect it, but he's overlapping the x-axis. How does that work?
It'll
Just still
other
reflect
part that's
them.
Okay,
overlapping.
so this point is going to go down below the x-axis. So right now it's 2 units above. It's going to go the same, but 2 units below. Do you see that? Okay, this guy is 2 units below, so he's going to go 2 units above. And this guy is 5 units below, so I'm going to go 5 units above, and there he is. Do you see that? Confusion?
Yeah, that makes sense.
Yeah?
Wait, what?
Okay?
That does make sense.
So I take each point, and like if it's 2 units above, I'm going to go the same spot, but 2 units below the x-axis. 5 units above, 5 units below, and then I connect my dots, right? So he looks like this.
Wait,
Okay, so like Carson, this point is like 5 units below the x-axis. 1, 2, 3, 4, 5. Now I'm going to turn around and go 1, 2, 3, 4, 5 above, and that's where he's going to live now.
oh, so
instead.
you swap.
Yep. Yep,
So
so you
I
just
don't
swap
know,
them.
you flip 'em.
Yep, you just swap them. Okay, so my pink one is where he's going to end up. All right. So here's the deal. I'm going to go over here and I'm going to look and see, and let's do this. Okay, I'm going to write them here. Do this for me. A is at 3, 2. B is at 2, -2, and C is at 4, -5. Put these in the middle here, okay? And what we're going to do is we're going to talk about where the coordinates or what they look like when we flip them over the x-axis, right? Okay? So if I flip them over the x-axis, this 3, 2, which was this dot right here, moved to down here. Do you see where my black dot is? So 3, 2 moved to 3, -2, okay? Now 2, 2, or 2, -2, which is this dot,
2,
became
2.
this one. 2, 2 switches to become 2, +2, right? Yeah? Like he switched from 2, -2 to 2, +2. This dot right here is 4, -5. He is switching to be
4, 5.
4, +5. Okay, so let's write a rule over here. Here's my rule. Rule x-axis, if I'm reflecting over the x-axis, this is what you're gonna make reference to when you go to do your homework assignment. If you are flipping across the x-axis, okay, and you have an x and y coordinate, what happens to that xy coordinate? How does it change? The y coordinate
It
switches sign, right? Okay, so what I'm gonna do is I'm gonna call that x comma negative y, right?
Zoom out.
So you make the x coordinate negative. Now, if the x coordinate is, or excuse me, the y coordinate negative. If the y coordinate is already negative, a negative negative is gonna turn it positive, right? Okay, so you are flipping the sign of the y coordinate if you are going over the x axis. Make sense?
Indubitably.
Okay.
Inconceivable.
Now over here, if we're going across the y-axis, I'm going to put his
Alright,
rule
that's
over
the
here.
Y changes.
If you go over the y-axis, and you had to guess, his x-coordinate is going to change. It's the opposite. The opposite coordinate changes sign. The y-axis, the x-coordinate is going to change sign. So what I can do is that helps me kind of cheat, and I don't even have to graph it first. I can figure out. Okay, we're going from here to here. If I take that original one,
So
3, 2,
It'd be -3.
negative 3, 2. What about 2, negative 2? Negative 2, negative 2, right? What about 4, negative 5?
-4.
Negative 4, negative 5. Okay, we just switched the first coordinate,
they
and this
both
is
have to
across
go
the
negative now?
y-axis. What?
Why are they both? Oh, they both have to go negative.
No, they don't both have to go negative. But was that, no, I'm looking
Oh,
at
I
this
just
one
mean
being the
like-
original.
Yeah.
Yeah, so if I'm going across the y-axis, I
Oh.
only change the
I
sign
don't
of
know why.
this
I
side,
was
right?
like not looking at the original. But
Yeah, you're looking at this one right here, yeah. So I only change the sign of that first coordinate, the 5 stays negative, yeah? Okay, all right, so then I can use that to graph. I can do
Is it
cancel.
-2, -2?
Yes, negative 2, negative 2. Okay, so my original guy was 3, 2. I'm just going to graph these really briefly. 2, negative 2, and 4, negative 5. No, wait a second. Gosh, I can't do the math here. 3, 2, negative 2, and 4, negative 5. There we go. Okay, this is my original guy. And I'm going to then plot these points, which is negative 3, 2, negative 2, negative 2, and negative 4, negative 5. Oh, look at that. Now, is he the same shape and same size? Did he stay congruent?
Yeah.
Yes, then I know I did it right, right? If your object changes shape and looks funny, like when you write the second one, then you didn't do something right. Okay? Happy about that? But the rules are, you're gonna want to look back on these.
yeah.
That the x-axis reflection, you're changing the y-coordinate, making it negative. Y-axis, you're changing the x-coordinate, making it negative. Okay? Happy with that? Translation. This is the next one. Okay? So I'm going to write these coordinates down. This is Q is -8, comma -2. R is -9, -5. We're going to plot these. S is -4, -7. And T is -4, -2. I'm writing these down, and we're gonna write what he becomes. Okay, and I'm going to do this before I plot. I'm going to plot them both at the same time here when we get done. Okay, but in a translation, this is a slide. I'm like sliding it over, right?
So both.
This thing tells me how I am sliding it, okay? It's kind of in like triangle brackets, so you don't think 7, 1 is another point on your graph. 7, 1 is how you are moving it, okay?
Yeah,
So
over
7 is the
Yeah,
first
yeah.
coordinate, and the first coordinate is your x coordinate, right? So this tells me how the x is changing, and x goes left and right. So we are going 7 units to the right, because it's a positive 7,
And
right?
1.
So we're going right 7, and then this has to do with the y coordinate, right? And since it's a positive 1, that means we're going
Up 1.
up 1, right? So we're going to the right 7 and up 1, okay? Now, I can change my coordinates without actually having to graph them. All I do is add that to the existing coordinates, right? So if I take -8 and I add 7 to it, that gives me my new coordinate point. -1, what's -2 plus 1? -1. So -1 is what that guy is, okay? -9 plus 7?
That's 8,
-2. -5 plus 1
-4.
is -4, all right? Then I get my next point. -4 plus 7
3.
is 3. -7 plus 1,
-6.
-6. -4 plus 7 again, 3. And -2 plus 1. So I have my new coordinates. right?
That is pretty easy.
Yeah, very nice. Okay, so I'm going to plot my first one. -8, -2. I'll quit talking so it makes it easier. He's like a quadrilateral without a right angle somewhere. Okay, and I'm going to plot my other one. Okay, and so we have slid him over 7 to the right and 1 unit up. And the main thing is that he should stay the same shape and same size. If I could draw straight lines, he would be exactly the same shape and same size. And there he is. Okay, so that's the rule. Those, whatever those triangular brackets tell you how you are moving it, right? How you're moving your object. Okay, this last part is maybe the toughest part. I don't know. Rotations are kind of weird.
There we go.
Rotations are kind of weird. Are we ready for rotations?
No.
No, not yet. Okay.
Wait, what? Oh, 3 negative 1. I did something wrong.
It doesn't look the same.
Well, I did mine right. That's pretty epic game.
I put my negative 1.
Carson's gotta work for me.
Okay.
Hopefully for me.
Okay.
All right. We ready for example 5? This is rotations. There are 3 different types of rotations. There is a 90-degree rotation. There is a 180-degree rotation. And then there's a 270-degree rotation. Now, when you're rotating, you always rotate
Till the right.
clockwise or counterclockwise?
Clockwise.
Clockwise.
You always rotate counterclockwise, actually. And the reason for that is when we get into like trig class next year and when we start talking about angles at the end of geometry, all angles in standard position will start here and they rotate around this direction.
Well, yeah, that's because they
Right.
started the coordinate.
Right, like think of the quadrants. Quadrant 1, quadrant 2, quadrant 3, quadrant 4 go counterclockwise, right?
So that makes
Right?
sense.
So that makes sense. So that when you are rotating, I'm gonna put a little star that says counterclockwise. Counterclockwise. Now, if you are rotating counterclockwise 90 degrees, let's say I have like an object up here in the first quadrant, right? And I rotate that 90 degrees. What quadrant is he gonna be in now? If I'm rotating in 90 degrees, it's a quarter of a turn. He's going to be in the second quadrant, right? Let's say I go back to here and I'm rotating him 180 degrees. He's going to be in the third. He's going to be down here. If I rotate him 270 degrees, that's 3/4 of a turn. And somebody said, why isn't 360 on the list? Because that just gets you back to the beginning, right? Okay. Now here's the deal. If I'm rotating 90 degrees, let's do this. 90 degrees counterclockwise is right here, right? Let's say I want to go instead 90 degrees clockwise.
Negative 90.
It'd be like, yeah, it would be like negative 90. But if I want to go 90 degrees clockwise, what could I do instead? 270 counterclockwise. So this is the same thing as 90 degrees clockwise, right? 90 degrees counterclockwise is the same thing as 270 clockwise. Does that make sense?
Yeah.
And 180 degrees counterclockwise is the same thing as 180 degrees clockwise,
We have
right?
to put that
Those
down.
are the same thing, okay? So I'm just saying that if they give it to you and they ask for, I don't think they're going to ask for clockwise, but if they would, that just means the opposite one counterclockwise. All right, so here's the deal, okay? I'm going to give you the rules. The rules for 90. Your x and y coordinates are going to trade places with each other. So it becomes y and then x. So you're literally going to flop them. And this coordinate right here becomes negative. If it's already negative, you make it positive. So you flip them, and that first coordinate becomes negative. Okay?
Like
That
after you
makes
flip them,
sense.
it
After
becomes
you
negative?
flip them, that coordinate becomes negative. The first coordinate becomes negative after you flip it. Okay?
Wait, why is it?
What
Wait,
if
the
it's
coordinate
already
becomes
If it's already negative, then becomes positive.
like the quadrant.
So like for example, like let's say 2, -3,
You'd
I would
it and
flip
it's
them and it would become
-3,
-3,
two,
comma 2,
but
but
it'd be positive
this
three.
guy would be positive 3.
Yeah.
Does that make sense? You flip them and you make that coordinate the opposite sign. Yeah, okay?
That's easy.
All right, let's do 270 because those kind of go hand in hand. Okay, X and Y, this is going to be similar to 90, right?
Yep.
Similar to 90 in the fact that they're going to switch places, Y comma X. But this time, the second coordinate becomes negative. So like, let's say 4 comma negative 2, okay, would switch places, so it would be negative 2 comma 4, but the 4 would be negative, right? You would strap a negative now onto the 4. Does that make sense?
That's
That's how that would change, okay?
So they would trade.
They trade and the first one becomes negative here, the second one becomes negative
I
here.
have a
Now,
feeling-
how do you remember that? 90 comes before 270. So this is the first coordinate becoming negative, this is the second coordinate becoming negative. Does that make sense? Okay, first one, second one. All right,
Do you flip
180. 180, this is my favorite.
those? You flip those.
180 degrees, you don't flip them.
Never mind.
Okay, here's how 180 works. Let's say I had an object here, right, in the first quadrant, and he's gonna end up over here. 180 degrees is exactly the same thing as flipping it or reflecting it across the x-axis and then reflecting it across the y-axis, okay? So let's think about reflecting across the x-axis. What does that do?
It makes it negative.
If you reflect across the x-axis, the y-coordinate becomes negative, right? If you reflect across the y-axis, the x-coordinate becomes negative.
Told you.
So 180 degree rotation, they stay in the same spot, but they both turn the opposite sign, right? Because it's a reflection across x and y at the same time. Okay? Good?
That's what I was saying.
All right, I got lots of stars going on up here. Whoop. Okay, so let's do some stuff. Let's write these coordinates down. I have F is 2 comma 1. I have G is 7 comma 1. I have H is 6 comma negative 3. And J is 1 comma negative 3.